Hi, this lesson is about cofunctions of trigonometric functions as well as the addition and subtraction formulas, also called sum and difference formulas. So first let's talk about cofunctions. Sine and cosine have a relationship to each other as well as tangent and cotangent. So the sine of an angle is equal to the cosine of 90 degrees minus that angle. The cosine of an angle is equal to the sine of 90 degrees minus that angle. So your angle here could be in degrees or radians. So these statements are also true. The sine of theta would also equal the cosine of pi over 2 minus theta if you're in radian mode, or the cosine of theta equals the sine of pi over 2 minus theta. Remember, pi over 2 means equals 90 degrees. The similar relationship exists with tangent and cotangent. So tangent is equal to cotangent of 90 degrees minus theta, which is the same as tangent is equal to cotangent of pi over 2 minus theta. And also cotangent of theta equals tangent of 90 degrees minus theta. So therefore it's also true in radians. Cotangent of theta is equal to tangent of pi over 2 minus theta. So a mistake that I often see students do is that this is not true. What I'm going to write here on the right. This is not true. For example, if I take the cosine of pi over 2 minus theta, cosine is a function, not a number or a variable. So it is not equal to, you cannot distribute this. So this is not true. So be careful not to do that. So let's just look at these cofunctions. Here's an example. If cosine of 48 degrees equals the sine of theta, then what's theta? Well, in order for the cosine and the sine to be equal to each other, with the exception of 45 degrees, but it still works in these formulas, then you have to figure out what the corresponding angle is for them to be equal. And so remember, that means that you have to subtract 90 and theta. So 90 degrees minus 48 degrees means that the theta is 42 degrees. So what that means, and you can check it with your calculator, that means that cosine of 48 degrees equals the sine of 42 degrees. Example 2. So we want to verify that the cosine of 48 degrees and the cofunction sine of 42 degrees are equal. So it's exactly what I mentioned above. So if you plug these into a calculator, make sure you are in degree mode because your angles here are in degrees. You get that they are both the same approximate value of 0.6691. All right, so let's talk about the sum and difference formulas for trigonometry. There are several. The first two are regarding sine. Alpha and beta are angles. So sorry about that. So this is your alpha, and this one here is your beta. Okay, it's just distinguishing two different angles. So if you have the sine of alpha plus beta, that's equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. The difference formula here for sine is almost the same as the one above, except there's a minus sign in between in the formula. We also have sum and difference formulas for cosine. So here the cosine of alpha plus beta is equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And again, the formula just below it is almost the same. Cosine of alpha minus beta looks like the formula above, except the middle term here is positive. Okay, so formulas for sum and difference of angles for tangent are a little bit more complex because you have numerators and denominators here. So the tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta divided by 1 minus the tangent of alpha times the tangent of beta. And the formula below it is again very similar, except the term in the middle here is a minus and the one above is a plus. And in the denominator, you're adding, and the one above you are subtracting. All right, so, and here I'm just reminding you of what I stated before. These trig functions are not distributive. So I showed you sine and cosine, but it's true for all 6 of them. You can't distribute a function. So again, keep that in mind. So here we want to evaluate the sine of alpha minus beta with the following information. You're told that the sine of alpha is equal to 4/5, and that means it's in quadrant 1 if they're both positive. And cosine of beta is -12/13, and you're told that that means that beta is in quadrant 2. All right, so if I need to find the sine of alpha minus beta, it means that I have to use this formula here above, the second one in the box. So in order for me to use the formula, that means I need to know everything on the right. I need to know sine of alpha, cosine of beta, cosine of alpha, and sine of beta. But I was only given 2 pieces of information, sine of alpha and cosine beta. All right, so first let's figure out what cosine of alpha is. You need that. Again, here it is in the formula. I need to figure that out. I also need to figure out what the sine of beta is, also not given. All right, so I'm going to use my right triangle to figure that out. So here's alpha. Remember, sine is opposite over hypotenuse. So in order for me to determine what cosine of alpha is, I need to know what the leg is that's horizontal. This is one of those special triangles, 3, 4, 5. So I know that it's 3. You could also figure it out with the Pythagorean theorem. I also know that beta is in quadrant 2. So I'm going to draw my triangle backwards. And cosine of beta is -12/13. So that's -12/13. Okay, here's your right angle, your right angle. Okay, so that means I have to find what the vertical side is. And this is also one of those special right triangles that we should know. If you use the Pythagorean theorem, if you don't remember, here the vertical side is the number 5. And it's positive because we're in quadrant 2. So sine of alpha minus beta, you're simply plugging it into the formula that I put a star next to above. It's sine of alpha, which is 4/5, cosine of beta, which is -12/13. That's given. Then minus cosine of alpha. Well, remember, here's alpha. Cosine is adjacent over hypotenuse. So that is 3/5. And then sine of beta. So I'm here. Beta is opposite over hypotenuse. So that is 5/13. So when you multiply each set of fractions, the first product is -48/65. The second one is -15/65. And when you combine your numerators, -48 minus 15, that gives you a -63/65 as your answer. All right, so let's move on. This one is, this example 5 is asking us to reduce the given expression into a single term, so a single expression. So you're given the product of cosine of 2x minus y times the cosine of y minus the sine of 2x minus y times the sine of y. So if I'm looking at the formulas above, this formula, this expression that I see here looks the most like this one, the one that has the star right next to it. Because on the right side, I have the cosine of an angle times the cosine of another angle minus the sine of an angle times the sine of a different angle. So, but instead of calling them alpha and beta, we're using these x's and y's. So my alpha is the first angle, 2x minus y, and my beta is y. Notice that the left side says that that's equal to the cosine of alpha plus beta. So if the cosine of alpha plus beta, when I plug in what alpha and beta is, I have the cosine of 2x minus y plus y. But the y's cancel each other out, so your answer is just cosine of 2x. So the original expression has been reduced down to a single term. All right, so let me get rid of this and move on to the next one. That was our answer. So again, we want to reduce the given expression to a single term. Expansion of any term is not necessary, so we actually need to recognize which formula does this look most like. So notice that I have the sine of 3x times the cosine of x minus the sine of x times the cosine of 3x. So I have sine and cosine being multiplied with different angles, and then I'm subtracting sine and cosine with the angles flipped. So the formula that looks most like that is the second formula here, because the right side has sine and cosine minus cosine and sine, which is pretty much what we have below. So I need to write this in terms of the left side, sine of alpha minus beta. So if my alpha is the first angle and my beta is the second one, so I have 3x and x, sine of alpha minus beta is sine of 3x minus x, which is equal to the sine of 2x. Okay. We want to reduce the given expression to a single term. So it's similar instructions. Here I have the cosine of x plus pi times the cosine of x minus pi plus the sine of x plus pi times the sine of x minus pi. So I have two cosines being multiplied, and then I'm adding, and I have two sines being multiplied. So let's see which one looks most like that. So two cosines being multiplied, and then I'm adding, and then two sines being multiplied. That's what I see right here. So the right side is in the given problem, which means I need to reduce it down to the left side. So I have to do cosine of alpha minus beta. So we have to figure out what's alpha and what's beta. Okay, so that means that my alpha is x plus pi. My beta is the second angle, x minus pi. So the cosine of alpha minus beta is exactly what you see here. But be careful because the beta is x minus pi, so we have to distribute the negative in between. So when you do, the x's cancel out. You end up with pi plus pi, which is 2 pi, and cosine of 2 pi, well, if you remember, 2 pi on your unit circle is where 0 is. If you make one full rotation, so that means you have gone around 2 pi units, and this point is the point 1 comma 0. The cosine value is the x value, so cosine of 2 pi is 1. Okay, here's one of those proving problems. So we worked with proving problems in the last section. So I want to take the tangent of negative x and prove that it is equal to the negative tangent of x. Well, in order for me to be able to use my sum and difference formula, that means you have to figure out how to express tan of negative x as either a sum or a difference. So I'm going to let the negative x be equal to, it's the same as the tangent of 0 minus x. Once I write it as the tangent of 0 minus x, that means I have to use this formula here. That is the difference of two angles where my alpha is going to be 0 and my beta is going to be x. So notice there is a fractional expression. So that's what you should see below. This is the tangent of alpha, which is the tangent of 0, minus the tangent of beta, which is the tangent of x, divided by 1 plus the tangent of 0 times the tangent of x. Well, tangent of 0 is 0, so my numerator becomes negative tangent x, and my denominator just becomes 1. So you've proven that tan of negative x equals negative tan of x. All right, we'll do another one. We want to prove that the cosine of 3 pi minus x equals negative cosine of x. So again, we're going to manipulate the left side, cosine of 3 pi minus x, until it looks like negative cosine of x. So this is the difference formula for cosine, which is the fourth one in the box above. And so if I apply that directly into the formula, here your alpha is 3 pi and your beta is x. So you get what you see here, cosine of 3 pi times cosine of x plus sine of 3 pi times sine of x. Well, cosine of 3 pi is negative 1. Again, if I go back to my unit circle, 3 pi is right here. This is 3 pi units around. And the coordinates of the point there are negative 1 comma 0. Remember, the cosine value is the x value, so it's negative 1. So here I have negative 1 cosine of x. The sine of 3 pi, well, that's the y value here on the unit circle. So that's 0. So your answer is equal to negative cosine of x, which is what you had to prove. So you're done there. Okay, we'll do another proving problem. I have the sine of pi over 2 plus x. We want to prove that that's equal to the cosine of x. So again, we're going to manipulate the left side. We're going to use the sum formula for sine. It's the first formula in the box above. And when you do that, your alpha is pi over 2 and your beta is x. So when you plug it into the formula, you get that the sine of pi over 2 times the cosine of x plus the cosine of pi over 2 times the sine of x. And now we have to simplify because we can evaluate sine of pi over 2 and the cosine of pi over 2. And again, if I go back to my unit circle, you should really know all of the quadrantal angles on this unit circle. Pi over 2 is up here, and the coordinates here are 0, 1, which means that cosine of pi over 2 is 0 and sine of pi over 2 is 1. So that's what you see in this line here. Sine of pi over 2 is 1 times the cosine of x plus cosine of pi over 2 is 0 times the sine of x. So the second term is just 0. So you get what you were trying to prove, that the sine of pi over 2 plus x equals cosine of x. Okay, so now you're ready to try the homework for this section. Good luck.